So what I want to talk about today is going through and talking about select queries. So you probably already have been using these. We've done a little bit with them so far in the examples that we've done, but we've done fairly simple select queries, right? So we haven't kind of used the full syntax and talked about all the things that go into there, including we haven't really had a chance to sit down and talk about things like joining and working with your aggregate functions and working with your grouping. So that's some of the things I want to talk about here, but also on this I've got kind of here's what it looking at how do you translate your select query once you get it working, how do you go back and forth between SQL and knex, and what that syntax is. So I've got a lot of slides on there talking about that as well. So that's kind of the goal today, and that'll feed into your, showing data maybe from additional tables on your list pages, or feeding into showing data, like let's say you want to look at an order and you also want to see information from the products table, like the product name if you're looking at what's in an order. So that factors into there, and then the other thing that factors into is implementing searching. So that's kind of like what we'll look at once we go through the theory bits. We'll kind of look at how maybe we can apply that to this Cowboy Boots store. Okay, so let's start with talking about the syntax that MySQL uses and how that fits in. MySQL syntax is pretty similar to most other versions of SQL in these regards, but there are some minor differences, the main one being how limit is implemented. So the way that limit, offset, those kind of things are implemented varies a lot between different versions of SQL. So some versions of SQL, it's limit 10, offset 20. Other version, or SQL Server has a completely different syntax to do the same thing. This last one is the one that varies the most between different versions of SQL. Other than that, they're mostly very similar. Okay. Now, when we're writing a SQL statement, when we're writing a select statement, here's kind of the full syntax of all the clauses and all the pieces that go into it. So each of these pieces that you'll see, we call that a clause. So we've got the select clause up at the top. You've got kind of the from clause, you've got your joins, you've got your where, your group by, your having, your order by, and your limit. And as far as SQL is concerned, they have to be in this order. You can't have them in any other order. They have to be in that order. Okay. So you can't put the where after the group by, etc. You can't put the limit up higher. It has to be at the end. They have to be in that order. Other things that you might notice, you'll notice that some of these that I have the square brackets around. You'll see that. Why do those have square brackets? Any thoughts? Any guesses? Huh? They're not required. Okay. So if you look at that, what is required? It's just select. And that's the only thing that's required, because I can do things like, let me see if I can switch over to Jamboard so everybody can see it as I draw it more. So that means I can do things like select one. That is a valid SQL query.
First column.
No, it just says select one. Get the number 1 back. It just returns one row with 1 in it. I could also return 2, right? And that's actually relevant because that becomes helpful if you want to say, is there a row at all? Because sometimes you can just say, well, let's select 1, and there may be more stuff in there. There may be a from and yada yada. But this by itself is a valid SQL query. Can I change this so it isn't?
Why would you ever want to do that?
Why would you ever want to do that?
Well, yeah, like one, so what?
So what it would mean, usually it's in the case of something. Oh, that's what I want. I want to. There's my text box. So usually it's in the context of select one from maybe we had the order product, right? Is kind of the interim table. So the place that would usually come up is something more like this, and you would say select one from where, let's see, order ID is 3, and your product ID is 5, right? So here I'm saying, well, in my where, kind of working backwards, I'm saying I want an order product. I want this junction between there, and I want to know, is there one that has for order ID 3 and product 5?
So it's true or false?
It's basically true or false. Is there a row there? Is there not a row there? The reason being I want to know that is let's say I want to add something to my cart. Well, I need to know if it's there to know if I need to update the row or insert a new row, right? So if this comes back with a result, then I know that there already is a record there, that I've already added it to my cart, which means that I need to do an update. If this came back with no rows, then I would need to do an insert. Does that follow? It also means that you can do things like you can do calculations, because I can do, let's say, select concat. Concat would put two strings together. Right? So that would give me a single row. And I'm just basically saying, take these two things and put them together, call it name. So that's a valid SQL query. What were you going to say, Paul?
What does it actually return though? I mean, you see what, if it's true or false, not this one, the select one from.
Okay, so, well, what would be the name of the column? The name of the column would be 1. What would be the value of that? So it either return as 1, with a value of 1, or it would return nothing at all. So it would return as the name of the column would be 1, but there actually wouldn't be any records.
You don't have to call it 1, you could call it 12. It would return 12 and true.
Right, I just haven't given it a name. Right. So if I said as present, right, then that would be the name of that column. So I'd either get back a single row with 1, or I'd get a single, or I wouldn't get a row at all.
Okay.
And that comes up a lot, especially because you can take a query like this and feed it into the exists method, and the exists method will tell you, does this query give you back at least one result? So I often write things like this and feed it into exists in SQL. Does that make sense? As this would be kind of what we call a subquery. So what that means is this is the only part that is always required, right? That's the only part that's always required. The rest of those are optional. But if you do include them, you do have to include them in that order. Okay, so let's go through what those different clauses are. So starting from the top, we've got the select clause. The select clause is the whole reason it's there is to determine what columns you're going to get in your result set. That's it. What are the value of those columns going to be, and what are the names of those columns. So we've seen some of that already. I can do select star, get everything from that table, or everything from the everything from the table. I could do ID name, and that would return just the ID and just the name. Or I could do things like, well, I want to know how many products there are. So I could say select count, right? So that gives me the number of products. But then typically if I'm using one of these functions, I need to give the column a name, because otherwise the column would be count star, yada, yada. So I'm going to rename it as count. So anytime you see the word as, that's used to give an alias to either a column or a table. You can alias either one. Questions on that? So as is a helpful kind of tool there to alias things. The next part is the from, and typically the way you'll see it is you'll just see it with a single table. So the from just says, well, what table am I pulling the data from, right? It can actually have more than one table. So I could do select star from products, comma, customers. That is typically valid SQL. But what happens in that case is that those tables get what we call cross-joined, which we'll talk about later. Okay. It's usually not what you want. There are some cases and some good uses for cross-joins, but they're fairly rare. Most often they come up with where you want to look at a date range, and I want to say take a table of dates and cross-join that with something else. But those are kind of rare, but you can have that in SQL. The next part that you have is the joins. So this is more typically how we'll bring those in rather than comma, table, 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 table. In the from, we'll usually just put one table in the from and bring in the rest with joins. So for instance, here you can see I'm starting with the orders table. I've actually renamed it. Now, why did I use as there and not use as on the rest? I don't know. But we're saying grab the orders table, and you can see the O there. I'm aliasing it to kind of give it a short name, and that's typically something we do in SQL. I haven't found an easy way to as easy way to do that in knex. I think you still can. I think you can use the as function, but I've found it just easier to not alias it when working with knex. So orders, I can alias that as O, so keep it short, or join that with order products. So I want to bring both of those two in. Now, if we were looked at our ERD, we would see that the orders and order products are connected, right? There's a relationship between them, right? So typically when you're doing joins, you want those joins to be where there's a relationship. And so one side it will be the primary key and one side it will be the foreign key. You'll be joining that together. Okay. And that's kind of where those come in pairs. And then I'm also joining in the products table. Again, you'll see there's a connection, right? So I'm in effect, I'm ending up with a result that has data from the orders, the order product, and the product. Cool. And I'm doing it that way because that's where the connections are, right? If I were looking at the ERD, is there a connection directly from orders to products?
No, you get the rich data.
Right, we've got the order products in the middle. So when I'm doing a join, I can't skip one of those tables. If I want to get the orders joined with the products, I can't skip the table in between, because otherwise I wouldn't know the connection between the two. I wouldn't connect them properly. Cool? Did you have a question? Okay. You just had your hand raised.
Sorry, yeah, my nose kind of here.
Yeah, I couldn't tell. So that's kind of where that fits in. Okay, and we'll talk about more about joins in a minute because I've got a few slides on that. But the idea is there to bring in data from more than one table. Okay. After that, we've got the where clause. Where clause in general, the purpose of the where clause is to filter the result set. So for instance, here I might say, I only want products with a category of hats and a price greater than or equal to 10. Right? So I can tack on, I can do most of these just like you might think in C# or JavaScript. I can do comparisons, but I can, like equals, you'll note that my equals is a single equals. SQL is a little bit weird in the sense that single equals in SQL sometimes means equality and sometimes it means assignment. It actually means both. If it's an where clause, though, a single equals always means comparison. So we can have greater than or equal to, we can have less than or equal to. You'll notice that I'm writing out the word and, not ampersand, ampersand. Right? So that's the normal way that you write and in SQL. There's also an or. Again, you write it out literally. Some variants of SQL support doing ampersand, ampersand, and or. Not all of them do, but all of them support the word and all of them support the word or. The next query or the next clause that we have is the group by clause. And in general, the group by clause is take related rows and to group them into a new result set. So for instance, here I'm grouping the items by category, right? So previous to that, if I would say from products, right, I've got a row for each product, right? Once I say group by category, it goes down to a row for each category. Does that make sense? So it might be that I have 1,000 products, but when I group it by category, maybe there's only 4 categories, right? So I might only have 4 rows. Okay. One of the big advantages of grouping is it changes the aggregate functions. So like count and sum, etc. Normally they would work over the entire result set and collapse it down to one answer. Instead, they work over the groups once you group. So that becomes a very, very helpful tool to combine the aggregate functions with the groups. And in general, that's the only place where you need grouping is if you're going to use count or sum or things like that over a group. Usually we use those in unison. Okay. The next clause that we have is the having clause, and the having clause is very similar to the where clause. It's just that having happens after the grouping, where happens before the grouping. Okay. Where happens before the grouping, having happens after the grouping. And that does matter. So, for instance, one of the things that means is oftentimes if I want to say filter out data, let's say I wanted to filter out all the items that are $10 or less, right? I might want to, it would be different between having it before the grouping or after the grouping. So for instance, if I say, well, let's filter out the cheap items, right, before I do the grouping, then I might, not see some of the groups, or some of the groups might have a lower count, right, because there's fewer things in them. The other thing I might see is if I do it afterward, well, I can't get down to that anymore. I can't get down to the price of the item anymore in the having, because the price basically doesn't exist anymore. Right? Well, that's on a per item basis. So there's a lot of things. Sometimes you have to do in the where, sometimes you have to do with the having. The most common thing to do with having is to say that the count is greater than 1. So to say, what does that say? Well, that says, remember the count is on a per group basis, right? So that says the group has at least more row in it, right, in the collapse form. So I'm saying I only want groups that have at least one, or sorry, have more than one. So any group that only has one item in here would disappear, right? Any groups that have 2 or more would show up. Places where that becomes really helpful. Let's say I want to find duplicates. Let's say I want to find customers that have the same first and last name, right? So I might group them by their first and last name and say, okay, I only want the ones where the groups where it's more than one. That means I only have the duplicate pairs. Does that make sense? So this kind of trick, count greater than one, is the most common way, and probably almost the only way that having it gets used. There's you can do a lot of things with having. That's the 90% use case for having. You can do other things. I have occasionally done other things, but that's probably the most useful case for that clause. And the only reason that you can't do that in a where is, remember, because that count kind of depends on the grouping. So you can't do that count comparison before the grouping. So it has to be after. Okay. Next clause we have is the order by clause. And order in general, we can tell it to order by a number of columns. And I think that looks like I didn't update my text over here. But the general idea is to sort your results, right? To sort your results based on certain columns. So by default, most of the time your results will be based on the primary key of the first table that you brought in. So if I say from products, it would probably be on the primary key of products, right? So 1, 2, 3, 4, that would be the normal ordering of it. It can get a lot more complicated as your queries get more complicated, where the engine decides what order you want it to be. It wants to be in. So usually at some point you want to make sure that any of these queries you run that you expect to get more than one result, you really should have an order by clause on to make it predictable. So the order by, we can do things like we can say order the products by name ascending. That's what ASC is short for. Or I can say name descending. DESC. So I can use that ascending or descending with any type of data. So I can use that with numbers. I can use that with text to sort it different ways. I can also specify more than one column there. So for instance, I might say order by name ascending and then price descending. So you can just separate each of those by commas if you want to order by more than one column. That can be helpful for like first name, last name. Some people have the same first name, some people have the same last name. So you usually would say order by last name, first name, or first name, last name, and not just sorting by one column. If you leave off the ASC or the DESC, you leave off that order, it defaults to ascending order from smallest to biggest. That's the normal ordering of things. So the next piece that we have, so that's the order by, we have then the limit. So the limit says I want to limit the number of rows that I get back in my result set. So in this case, I'm saying I only want 10. Right, only want 10 rows. It's important to make sure when you use the limit clause, always include the order by, because otherwise you don't know what rows you're going to get back. Okay, if you don't include an order by, you don't know what the limit's going to give you. So if we order by name and then limit 10, we know we'll get the first 10 items. Versus if I said order by name descending, limit 10, I would be getting the last 10 items, right? So you can use that, the combination of the order by and the limit to really get what you want. So for instance, if I want the top 10, right, usually I'm taking the highest number, right? So I might take their score or whatever it may be, in order that descending and then limit 10, right? So I can combine those two. The other part of the limit clause, and this is how MySQL has implemented it, is you can put an offset before the limit number. So here I'm saying limit 2010. So that first number is the offset. It says how many rows do you want to skip? So it skips the first 20 rows and then gives you up to 10 rows.
That's 21 through 30.
Yes, so it gives you 21 through 30 if there is a 21 through 30.
Will it just return 5 if there's 5?
It'll just return 5 if there's 5. Yeah,
nothing
or nothing. Right. So if there's only 19 rows, then this is not going to give me anything. Right. But if there's 25 rows, then I'll get then it'll get 5 rows back. So that's really, really helpful. Using that offset and the limit is really helpful in making paging, right? So rather than displaying all your results at once, you can say we'll show 20 pages, 20 items per page, 10 items per page, whatever that number is. And that's something that comes in and becomes very important when you're looking at a lot of data, right? If I pull all the million rows and try to run that through handlebars and try to then send it to the user, right, that page is going to load really slow, right? So usually I only want to send them one page of results at a time. Does that make sense? For performance reasons. So that's how we implement the paging. It's part of the limit clause. You had something, Troy? Okay, what's your revelation?
I was trying to think of how you like use the graphic code or like repeat and get the non.
It's offset and limit. So that's a big part of that. So we kind of went over all of the clauses. The next thing I might mention is the order that these clauses execute in. And for the most part, it's pretty obvious. It's mostly top to bottom, except for the very top one. The select clause at the top does not run first. It doesn't run first. And that's an important thing to keep straight because it will affect how you have to write the queries and how the queries run. So the select clause doesn't run first. It runs kind of sixth before the order by and the limit. That's the order that things actually get executed in. So we say which table you want to pull it from, join in other table, filter it with a where, group it down, run the halving to filter out groups that you don't want to keep, figure out what columns you want to keep, or columns you want to build up with counts and sums and things like that, and then finally run the order by and the limit. So it's important that to understand that select runs in that order, and partially one of the kind of outcomes of that. Typically, when I write my select statements, I don't actually usually write the select part first. I usually leave that as select star until I get down to that point, and then I put it in, right? So I'll usually figure out all these details first before I change it from anything other than select star. Because I kind of need that in there and see what data I'm working with up until that point. Does that make sense? So that's what I would advise is push your select a little bit later.
Would you also advise whenever we're working with knex to do this in MySQL first, just to see what works and then try to translate it?
Yeah, I would recommend doing some playing around because part of that is that if you look at just at the knex documentation by itself, you're only going to learn about knex things, which is kind of what's standard across all of SQL. But if you want to, for instance, see some of the features that are maybe MySQL specific, such as a full text search and things like that, certain syntactic things, you kind of need to try that directly in MySQL to see how that's going to work out. So let's talk about those aggregate functions. You kind of saw them in a few of the examples already, but I want to just explain what some of those are. So if you say count star says it counts the number of rows in the result set or the group, right? So if I just say count star to grouping, it would say, okay, there's 20 records in your result sets. That's how many you would have. But you end up with just one record, right, that says they count. If I say, on the other hand, I say count with a column name, so if I say like count product ID, it will give me all of the rows where there's a non-null value for that column. Okay. There's a non-null value for that column. Okay. And that can be very helpful when you're doing things like left and right joins or outer joins. That's in general a very helpful tool to have, is to count by a column to fix certain kind of use cases that you run into. The other thing you might do is, let's say you set up your products and maybe you made the price optional, right? Maybe I want to find out how many of my products don't have a price, right? So if I did count price, then that would tell me how my products have a price, right? And then I could just say, okay, I've got 100 projects, 20 of them have a price. That means 80 of them don't have a price, right? That's probably a problem, right? So that's where you can specify the column name. Most of the time, we just do count star because I just want to know how many rows there are. But sometimes you do want to know how many non-null values there are. Similarly with sum will go through and add up the values in that set, in the group or the result set. And specifically sum you're always going to use with numbers. So I might say, let's sum up the price, right? Let's sum up the price of everything in your order. Okay. So I can do that. But what if my items in my order have a quantity in them, right? I can't just sum the price. Does that make sense? So if I want to maybe work with the price, if I want to figure out the price of an order, well, what would I need to do? I need to do some sort of multiplication. So on a line-by-line basis, let's say we have product, I ordered X number, each of them were this many, right? So I need to say, on a per item basis, I might say the quantity times the price, right? So that would give me, on a line-by-line basis, sort of a subtotal, right? But then I need to then go, well, all the products you added, all the products in your cart, we need to add all that up, so I might say sum. Does that make sense? So if I were to go all of the over all of the items in your order, I could do something like this, and I would get the total cost of the order. Does that follow? So one of the things that means is it's also worth understanding that sum can actually take an expression. So sum can take any sort of expression that you run on a per record basis, per row basis. So I could add those two up. I could do multiplication, whatever it may be. I can look at a single row, run a calculation, and then add up all those calculations using sum.
That would be its own row too.
What do you mean its own row?
That computation. Right?
Well, what'll happen is when you do sum, you have a collapsing. So either you're collapsing because you have a group.
One row, right?
Right. So you already have one row. So if I'm running the sum, I can't get the individual price for each item in the order. Does that make sense? I can only get the total.
Yeah.
So you either get the total or I get the individual prices. Questions on that?
So let's say you try to get the total. Would you run that as a query and then take that result and then plug it in as an update, or would you run that in the update query?
What do you mean run that in the update query?
So you're trying to find the total price for the order.
Okay.
And you get what you did before, so the total becomes the price for all of their items.
Okay.
So what you do in an update query.
But where is this update? What I'm asking is, where is this update query happening? What is the goal of the update you're trying to write?
You're trying to actually set the total price to what?
Okay. So there's two approaches. One approach is what we call denormalization, and you don't store the total at all. So that's one approach that you can take, is just don't store the total, because wherever you store as a total is probably going to be wrong, right? Because it's based on the data in the order items or the products table. So if I put it into the orders table, there's a good chance that it may be incorrect because it kind of depends on other data. The other way to go around it, though, is sometimes it is worth having that in there for two reasons. A, for record keeping, because I want to know how much did the customer actually pay, right? And if I have that out with other data not in the order table itself, it may actually be hard to determine what they actually paid. Because other things, all that other data maybe can change. So there is some benefit there. There's also some benefit in terms of running your query and having simpler queries. So what I would say is maybe what you're thinking is having that total there, but updating it when you add something to your cart. Is that what you're thinking? So effectively what you'd have to do if you were keeping it on there and you're doing it when you're adding to the cart, is that right? This is the scenario we're talking about? Okay. So you first would need to do the update or the insert to put it into your cart, to put it into the order. Once it's in the order, then I need to do an update. So I actually have to do potentially the insert first before I can calculate the actual price. Does that make sense? I have to add it to the order, and then I can update and recalculate. So it'd have to be two separate statements to do that. So sum is helpful there. You can say sum a single column, or you can say sum any sort of expression inside of there. You can also say, let's take the average. So maybe I want to know what the average price for all my items is.
Ignoring the nulls.
Right, ignoring the nulls, which average does not count the nulls. You can say, well, give me the average of either all of the items, if I just say average, or I can use a group by and say, well, give me the average for each category, right? So then I can find the average for hats is $5 and the boots is 10, etc. So the average I can do with AVG. Some versions of SQL it's average spelled out. Some versions of SQL it's AVG. So that's one of the things I always have to look up depending on which version I'm working with. There's also a min and a max. So a min gives you the smallest value for a column. A max gives you the biggest value for a column. One of the things it doesn't give you, though, it doesn't tell you which row is the min and which row is the max. So it'll tell you what the minimum number is, so I can find like the minimum price. Yeah, I can find the minimum price, but it doesn't tell me then, the baby boots are the cheapest item, right? It just tells me what the cheapest price is, or what the most expensive price is. So you can get that, but it turns out it's actually quite a bit more complicated. And sometimes, especially if you just want the highest or lowest, the right answer is just order by descending or ascending, and limit 1. So sometimes, oftentimes, if you just want to get the highest or lowest row, it's actually just better to order by a limit. So this is purely if you want to get the biggest and the smallest value. Okay, so let's take that and start translating it to knex. So, thing to keep in mind, knex is a query builder. Okay, it's going to help us build queries, and one of the things that means is while SQL is very strict about the order of those clauses, because we're building a query builder, we're using a query builder, it's not strict about that. Okay, so while SQL may be strict about the order that you have to write those clauses in, knex is not. Knex allows you to write them in really any order. Now, typically you'll notice when I looked at the execution order, notice what's first, the from, right? So that's typically what we'll put in. That's what you'll see first when we put in knex, is we'll do the from first, because that actually makes the most sense as being the first thing to do, rather than having the select be the first thing we do. Is say, which table are we working with? So the order we write it is not the same as the way that the SQL is going to be executed. That's one thing to keep in mind. However, doing that, the fact that it lets us do that and kind of lets us put the queries out of order also makes it easier to modify the queries dynamically if you need to add in additional clauses. So for instance, if you want to say, well, the user has a filter that they can choose to filter by category or not, I can just say, well, let's not put in that where clause if they're not filtering by category. But if they say they just want hats, well, then we can add in that query. Or if we say, well, maybe they have a drop-down that lets them order it by different things, right? That then can be something you can just take a switch statement and say, well, if they pick this, order it by this, order it by this, order it by this, makes it a lot easier to tack on that order by clause. Okay, so keep that in mind, right? That means that we can build it more dynamically. Okay, so let's talk about the select, right? So select is pretty simple. If I want to do select star, it's knex table name, select star, right? So we've already seen that one. If you want to do more than one column, so in SQL, I would separate that with a comma. In here, I would separate that with a comma, but it's a kind of a list of names. Does that make sense? So this here is equivalent to that. Okay. If I want to do a count, knex has kind of chosen an interesting option in the sense that if I want to do counts or similar aggregate functions, I can't just put it in like count here in the select. You actually have to use the count function. So the syntax for doing this, you say count star as count, is actually I call the count function instead of select function, and I say star as count.
There's no nesting, in other words. There's not a lot of nesting.
You can do nesting. It's actually nesting in code if you do it with knex. But nested subqueries are generally something that's kind of, if you need to do a subquery, you should be writing it in SQL anyway. So for instance, I think I talked with some of you about doing store procs. If you need to do a nested query, you should probably be writing a store procedure and not doing it through knex anyway.
How would you do that in code though? I mean, I understand querying the database, but how would you call on that?
So a store procedure is a way to write basically a function in SQL that you can then call later. So you can write any SQL code in there, stuff it in there, and then you just call it with the name of it. Which means that if you're writing a store procedure, you don't actually have to translate it from SQL to knex or whatever your language of choice is. Does that make sense? If you're using a store procedure, you don't have to translate it into C# or Java or JavaScript or whatever.
It seems better. I find
it depends. You're limited a little bit on running things more dynamically. So especially when we're doing things like searches, there's some value there. But it also takes more setup to set up store procedures. So that's what I would say. If you're using subqueries, you probably should just jump all the way over to a store procedure.
you're going to show us how to do that.
Not on this lecture. No. So you can do, if you want to do a count, use the count method instead. So I would say count star as count. That will rename it, alias as that. Or if I want to do count A, let's say I talked about you put a column in there, then I would write that as A as count. Right. So that first part is basically the name of the column that you're putting in there, and then that second part after the as is the alias that you're going to give it. Okay. If you look at their examples, they've got a bunch of different ways to do it. I would say this is the easiest version of the syntax options that they provide, and the one I would encourage you to use. So let's say, for instance, I want to do a select and I want to do it with multiple columns. There's actually more than one way to do it, right? So I gave one example that I could do it this way, right? So select A and B. One of the problems that happens is I can't do that then if I want to put in a count, right? So you got to think about how else could you do that. Well, I could write it as A and B, but I could also write this as select. That works as well. So selecting A comma B is the same as select A, select B. So I can actually call select multiple times and continuously add more columns to the result set. You with me? So sometimes the way that you translate it is you call that function more than once. Sometimes that's part of the translation. And unfortunately, a lot of the examples I haven't seen any of the examples where they do that and call the same function multiple times, even though that's a very important technique, is to do that. So if I want to say, for instance, I want to get A and I want to get count B, the way I would write that is select A, count B as count. Do the same trick where I could add in more things to the result set. That still returns one row. Yeah.
Yeah, the bottom two.
Mm-hmm. Does that follow? So you use count and sum that way. You just basically say, here's the columns I want to get, plus the count, plus the sum. Add those in as separate calls. Translating wheres, we've seen the equals. Equals is the simplest version. You just say, well, here's the name of the column, and here's the value I want to compare it with. So A equals 3, that converts over here as A, comma 3, or the value. Okay. And more often than not, you'll end up having this as a string, A as being the name of the column, and you'll have a variable that usually ends up having the same name. So this will usually be as price, comma, price, or category, comma, category. It's just that the first one will be a literal string, and the second one will be your variable.
If you have more than one layer, you don't type and just do another dot layer and put it in there.
Yes. So if I want to put in a comparator there that's not equals, not the equals symbol, then I put that in as a middle argument. So here I'm saying A greater than or equal to 3. That's where I put that in there. Similarly, if I want to do like, I put that in as a middle argument. So remember, I can do this like statement, and that says, well, go find this piece of string, this string in the string somewhere, this keyword. So for instance, this will find anything that has test in it, right? So the percentage sign means any characters before it, and then this percentage means any characters after it. So that's anything where the column B contains the word test. So that translates over this way. Okay. So that's how you translate some basic where clauses. Yes, as you were saying, if you need to do an and, there's actually more than one way to do it. One way you can do this, I want to say A is 3 and B is 5. I can actually write this as an object. That's one option. I can say A colon 3, B colon 5. That's the same thing. Or I can write it as two wheres. So I can write where A7, where B9. Both of those give me ands. Either using an object with properties like that or using multiple wheres. Cool. So that's how I get my ands. If you want to get an or, you say where, and then you say or where. That's the syntax they use. So
that should be in order, naturally.
Yeah, the or where would need to be second. So you say A is 10 or where B is 11. So that's the syntax that they use. If you want to compare things with null, it's worth noting in SQL that is a special comparison. If I write if I go into SQL and I write A is equal to null, this will never produce any rows, ever. This never works in SQL because this always comes up false. Even if A is null, this is false. Well, the thing that so there's the rule in SQL, and this is actually per the SQL standard. If you have null on either side of the comparison of the operator, the result is always null. It doesn't matter what the comparator is.
So how do you find your null values? You want to find all the rows where something's not there.
Right.
Is that it?
So it's A is null. This works, that doesn't.
The syntax back there on the slides, why are there no quotes around the A?
Because they're optional.
Always? Or just in this case?
It would be optional as long as remember the quotes there are for saying that I am missing quotes. The thing on the left they're optional. They're not optional on the right.
Okay, yeah, that's what I had.
No, you're right. I was looking on the left. I'm like, here they are optional, but no, on the left they are not.
Okay. Are there any,
Sorry.
there's no template grade marks or whatever? You don't use those there.
Yeah, you don't need to because it'll automatically put them in.
Oh, okay.
When you're writing with knex, it'll automatically put those grades in for you.
When you format.
When it actually runs the SQL.
Okay.
When it actually runs the SQL, they'll be in there. You don't need to actually put them in here. Cool. So if I want to say it is null, I want to find all the records where there isn't a value there. For instance, where the price is null, which we were talking about previously, then I would need to do this, is null. Because equals null doesn't work. And yeah, as I was saying previously, that it comes down to the rule that anything that compares with null is false. So that fails always. And in fact, one of the weirdest things in SQL is that is always false. Null equals null is always false. That's false. This is false. But if I were to write this as A is
null. Why would you
null.
ever write that? Null equals null?
You don't typically write that directly, but you end up with that when the left thing is when the left or right thing is a variable, right? Usually what happens is one of these is like A. So that's where this comes up. So this would be true or false. That could be either way. So yes, there's a special comparison for null, and it is the word is. And you literally only use the word is if you're comparing with null. Otherwise, you use equals. That's one of those weird things that just is just what SQL decided to do. You compare it with null, you get false.
That's 70s technology, right?
I mean, I think
technology, right?
it is. I think that, I mean, I know the idea of it is to make sure that if it's a null, it's kind of invalid data. So they're trying to keep invalid data out there. And the idea at that point was to keep the technology simple. But it means that you have to kind of write more code when it's not, when it might be null and you might care about it. So similarly, you can write is not null. You want to find only the values where it's not null, where it actually has a value. That would be where not null, the way that translates. So where null, where not null. Or in SQL, you can also say A is in this array. So A is in 1, 2, 3. There's a lot of different ways that you can do that. Usually it ends up being strings that you're comparing it with. It could be numbers, but usually it ends up being strings as the array. The way you write that in knex is where in. So where in, column name, and then an array.
inside the column, instead of a number or a string, it would be an array.
What do you mean?
I'm trying to understand where A in the array of 1, 2, and 3.
So this is true if A is either 1 or 2 or 3. If it's one of these values. If it's 4, this is false.
Okay. What does A represent? I'm trying to.
The name of a column. Name of a column.
Okay.
Just put in, substitute whatever cover column you want there. So, for instance, if I want to say the category, I could say, well, the category is belts, boots, and other.
Hats. Yeah.
Belts, boots, and hats. That's where you would probably see this. Is where you're saying it's in this group
all this
of.
buckle is in products, the product column.
Yeah, I'd look at like the category column there. Yeah.
Okay.
Or you might say, maybe you've got accounts, right? And I want to get all the accounts that are verified, like they verified their email and the ones that are deleted or deactivated. So deactivated and verified, or unverified and deleted. I could get both of those together. It's kind of shorthand for a where. I mean, shorthand for or, because I could say where A is equal to 1, or A is equal to, or A is equal to 3. The catch is with this in, it's an array, and it can actually be a whole nother, because select statements, right? They return a result set. A result set is kind of like an array, right?
Yeah, it is an array.
I can actually put a select query inside of that in, which is where this becomes really strong, because I can throw another select query inside of that in, which is inside of my where clause.
If you got a real life example of that, I'm having trouble visualizing through the theory.
Yeah, I don't have one offhand, but I've done that a lot. Putting select query in your in is very, very common. It's a very common trick in a lot of different solutions.
Like in the video. Right?
I don't remember. Might be.
Okay.
But it's a common trick. Either way, that's one of the things you can do. Group by would be the other one. So group by, you're going to say, easily translate, just group by columns A, columns category, you group by category. If I want to say group by first name and last name, I'd write it this way in SQL. It would be group by first name, last name.
Yeah, and that's order is important there.
Actually, order doesn't matter there.
Oh, it has to matter, wouldn't it?
No, because it just matters, it's basically grouping unique values. So the order of the columns you put in group by don't matter at all.
I'm trying to think of like first name and last name.
Yeah, but if I group by last name, first name, I get the same result as first name, last name.
How's that possible?
I'm not doing order by, I'm doing group by.
We'll have two groups, like if we went by first name, like you and I would be in the same group. But if you did it the other way, we wouldn't be.
So if I have markers not working.
My brain just stopped. I thought that was like the actual projector.
So if I have John Doe and John Doe, right? Their first name's the same and their last name's the same.
Yeah, they'll always be grouped together.
Maybe they're A Joe and B Doe, but either way, they have the same first and last name, right? So if I group them together, let's say I group them by first name and last name, right? Well, it'll pull that as that pair, John Doe. Well, is the pair John Doe the same as John Doe?
Yeah. Okay. So it's composite. It's a composite thing.
Right. It basically becomes a composite thing. So those would be the same. But if I flipped it the other way, right? Is Doe John the same as Doe John?
Mm-hmm. How would you do it by first name and then last name? not getting it for some reason.
Well,
They have to be done together, right? There's no other way.
Right. If I just said group by first name, right, I would be saying everybody that has the name John, let's put them in one group. If I were to just group by their last name, then I would be saying everybody that has the last name Doe, put them into one group.
So it's the first name and the last name together. Only people with the same first and last name are in a group.
So there are cases where you may want to do that, right? If I want to find all the Pauls, then I may just group by first name. If I want to find all of the Smiths, I would just group by last name. But if I want to find all the Paul Smiths, I need to group by both of those.
Okay,
but it doesn't matter what order. But it doesn't matter what order you group by, because it effectively becomes a composite thing, and you're saying, well, I only want effectively the unique pairs is what you end up with.
Okay, composite. That's what I needed to know.
Having the simple case of having, let's say you want to do a comparison similar to how you do where, is pretty straightforward. I can do it like if I just want to say A is equal to 1, it would be just A1. If I wanted to say A is greater than 1, it would be A greater than 1.
And that works on strings.
Works on strings, works on any data type.
Meaning like having a name greater than P.
Right.
Example.
Yes.
Q
yes.
And auto.
Yes, that you could do that. You could do that with there. However, you remember I said the most common case that you do, having count greater than 1. Turns out that getting count into your having clause is not the easiest thing to do in knex. So the way that I translate that to knex is you actually use this function called knex raw. This is one thing you want to avoid as much as possible, but there are cases like this where you need it. Knex raw says literally take the SQL that I've given you and plug it in. Just trust me on it. So I said here's the SQL I'd like to have, right? Count star greater than 1. Let's just plug that into the having clause. Just trust me on it, because there's not an easy way, there's not a way to really write that in the functions that knex has provided.
So could you just do like, instead of, how does it start? Select, parentheses, products. Instead of doing that, just knex, parentheses, product, you can just type knex, raw, and then whatever word in SQL
you technically could, right? You could say knex raw and just put in whatever SQL you wanted there, but you really shouldn't do that, because then you're not getting any of the benefits of knex, right? So you should use as little raw as you can.
What's the main thing in knex? What value does that add?
Well, part of it is remember it's a query builder, so it helps you build queries. It helps you add on clauses or make statements that are more dynamic, right?
You mean flexibility in the model?
No, I mean dynamic. I don't mean flexible. I mean dynamic. So what I mean is the query that you write is determined by the inputs of the user. Especially when you're talking about search interfaces or things like that, maybe they have 5 or 6 drop downs and checkboxes and things that they can pick, right? Well, each of those controls influences your query.
It changes on the fly.
Yeah.
And the knex raw is hard-coded.
Yeah. So the SQL changes on the fly. That's right. Yeah. If you put it in knex raw, you're saying take this SQL and just run this SQL. It doesn't make it easy for you to build the SQL. The other thing that you have to worry about if you're using knex raw, you have to pay more attention to SQL injection. If you use these other statements, you don't really have to worry about SQL injection as much, because, well, this 1 here, it knows that 1 is data. It won't try to treat that 1 as code. Does that make sense? If you write knex raw, you have to be very, very careful about what is data and what is code. And specifically when you're using knex raw, there's a special character called the special character, which is the question mark, which you use the question mark to replace parts of the statement with parts that are dynamic. Does that make sense? So the most dangerous thing to do when you're is say knex raw and then go let's say this plus that is and pull that in from the user. So if I were to say where did I lose it? If I were to say let's say knex.raw and I want to have a where clause, so I might write okay, so that's fine, right? That's fine, right? The user can't just inject any data into it, right? But what happens if I say a I have just given them permission to delete everything in my database. Don't do that. Right? So the first option,
I'm not understanding why I would delete the whole database.
Well, because you've just given them permission to write any SQL code that they want and pass it in as the quantity.
Oh, okay.
So, comma. Remember the little Bobby drop tables?
Yeah. Dot.
This is Bobby drop tables. This is where Bobby drop tables drops your tables. Okay. So this is not what you want to do. This first option is safe. This one is really dangerous. And then the next one, let's say the right way to write this, the safe way to write this is you say A is equal to question mark. This is safe. This is deadly. This is safe.
Yeah.
This is deadly.
So what I'm hearing is second optional. I'm just saying, if you want to live a life thrill,
I know. There are a lot of newbie developers will get in and get they get in the practice of, well, I can just write SQL's just code, so I can just add all these things up with pluses, and then you lose everything. I can't say how many times I've seen production code that looks like that. Honestly, it's embarrassing.
I just said, if you really love to add data to your database, that's the one to go.
If what? If you what?
Love to add data back to your database, that's the one to go.
Well, if your users, the question is who is adding that data back to the database, because it's gone. You're not getting it back.
Yeah.
And your users might be leaving you. They might not be coming back because you just lost all their orders.
You're not going to talk about that. If you just like to add data back.
I don't get how you'd insert the code in there, but yeah, that's all right.
What do you mean?
Well, I mean, I don't know. One's got the square brackets around it, the other one doesn't, and the question mark. What would be the interface with?
So this array here, that gets used to replace every question mark that you have. So I might say,
And A and B would be what, for example?
well, in this case, they'd probably be price and quantity, but I only have so much place on the screen. Right. So the array, they replace the question marks in sequence from left to right. So the first question mark gets replaced by quantity. The second one gets replaced by price.
Can you do that up for like many times? Like we just added like 7 different tables. You just do that in one thing.
If you added 70 different what?
Tables.
Maybe you could. But if you have 70 tables, who has the patience to create 70 tables? I think if your database has 70 tables, you probably have a bad design.
I'm saying if you are willing to create 70 tables, then you're probably willing to do the first or the second one. The second line.
Yeah, well, I guess that would get you back to a clean slate. But we try not to be that nuclear. So
you're saying if you use that with an insert, for example.
Well, that could be with anything really. You could do that question mark with anything where you need a raw.
Okay.
So let's say order by. Order by would be the next clause we need to talk about. Order by, just single column, is fairly simple. I just say order by name of column. If I want to order by multiple columns, the way you do that is order by and then order by again. There's not a version that takes A and B. You can't write this as just one order by. They don't support that. So it has to be multiple order bys. If you want to do it order by descending, then that's where that second argument is either ASC or DESC. And this is the reason that you can't do this actually as one statement, because that's how you specify if it's ascending or descending. So if you try to say A, comma B, then it gets confused and it thinks, oh, you mean to sort A in B order. Well, what is B order? It's not ascending or descending. I can't do that. So I need to specify it out that way. If I want to say A descending, B descending, that would look like this. Cool. So that's how you translate the order by to knex. Okay. Next up would be the limit. So the limit, we would say, if I just want a limit of 10, it's just limit number. So limit 10 here. If I want both the offset and the limit, then it's two separate statements. So limit 10, offset 20. So that's how I get my paging, which is what we were talking about earlier. Is I say limit is the size of each page, and then offset that's where I calculate and determine, which page I'm on. So for page 1, it would be an offset of 0, and then offset 10 for page 2, 20, 30, 40, etc. Basically goes up by my page size each time is how I do that paging. What do you mean auto set that?
So like if you were to have like 3 pages,
to do
every time, like offset 10, 20.
You have to do a calculation there, right? So I would just say if I've got this in a variable, right? So I say this is my page size. This 10 is my page size. I would say this is page size times page number.
Well, it's like thinking like, how would like Amazon do that? Like, because you can literally just keep going and going and going. Same with like Google. And I was like, I don't think they would. Like, there would have to be a way for that to just auto increment.
Okay. Yeah, you don't hard code this number. That's always going to be a multiplication. So, and that's where I was saying page size times the page number. And that basically gets you there. The trick is that the page number has to start at 0 for that to work. So usually you have to say page number minus 1.
You want to erase your John, Joe?
Yes.
Sorry, it was kind of bothering.
I forgot how to have it up there.
So let's talk about joining tables in SQL. Okay. So joins in general allow you to combine data from multiple tables. So that you can have like, I've got data over here that I need, I've got data over here that I need, I may have data from different places that I need to all pull together. So for instance, if I'm looking at giving you information about the items that are in your cart, right? I need to know from the order product or the ordered items table, I need to know for the interim table what items are actually there. But in that table, remember, we don't usually put the name of the product because the name of the product is over in which table? Usually in the products table. Why wouldn't we put the product name just in the order product table so we can get to it quicker?
Otherwise, you'd have lose the whole point. Relational database, right?
No, because that's not the point of a relational database. Is that would be duplicate data? Okay, it would be duplicate data because we're storing it in multiple places, right? So if we were storing it in both order product and product, in theory, it should be the same thing, right? So maybe I'm wasting some space on disk. As I kind of mentioned previously, space on disk is not really a concern. What is concern is space in memory. So it still wastes space in memory doing that. But what's really the downside? Because the storage space is really not that big of a deal, and it's not reason enough actually for us to do that anymore. Huh?
One more table to go through, right? It's not broad memory with it.
So what happens if I accidentally put in the wrong name for the product? Or the product name changes for some reason, right? Well, then I may have the correct name for the product in the products table and the wrong name in the order products table. Does that make sense? Well, they can't be linked. They can't be linked. So because I have the duplicate data, it can be inconsistent. And the inconsistent problem is the reason we don't do it. The data storage one is one that actually is not that big of an issue. Oftentimes it makes sense to make a duplicate because it's faster that way. Because actually, if I were to put the name over there, then it's quicker. It's actually quicker to go find the names of the products in your cart. That select query does not require join anymore, so it's faster. So if I put the name in there, it does make your code. It actually would make the website faster, but it would open us up to inconsistent data. Does that make sense? So there's a trade-off with duplication. Is you get a noticeable performance increase sometimes when you duplicate data in terms of reading the data. But then you have the consistency problem, which you can fix the consistency problem by making your writes slower, right? If I say, well, if I want to rename a product, right, I could solve that consistency problem. I could say, rename the product, we'll rename it in the products table, and we'll go through all the order products and change it there too at the same time, right? I could solve that problem. The consistency problem. And it's worth keeping in mind that is sometimes the right solution. Sometimes you bite the bullet and we'll say we'll have it in both places, and it will be slower to modify the data, but it's going to be faster to read the data because reading the data is the most common thing you do. Generally, your writes or changes to the data are oftentimes drowned out almost completely by the number of times that you need to read that data. If you think about your customers at an online store, most of their time is spent browsing. They spend very little time actually buying your products. Most of their time is spent browsing. If you think about the users on the back end as well that are looking at that and filling out orders, what do they spend most of their time? That are getting your order shipped. Well, they're mostly reading the data, right? They only have to do one small change in there to say, okay, your order shipped. Here's the tracking number. Like, the amount of work they actually do to modify the data is relatively small compared to the amount of reads that happen. So that's not true for every database. There are databases, especially if you're working with like smart home and technology and things that are generating data fast. Then you may see more writes than you see reads, but overwhelmingly most systems see a lot more reads than they do writes. Okay, so a join lets us bring in that data, and so we're saying, well, I need the name, for instance, is a common thing to pull the name from the products table. Or if I'm looking at an order, I probably want to know about the customer who made that order. So if I'm looking at a page that shows me information about the order, I may want to go join in the order table to find out the first name, last name, email, address, etc. from the customer table. Okay. So joins are a really important thing there. One thing to keep in mind, though, that the result when I do this join still has to be flat. In SQL, you really only get scalar values inside of rows, right? I can't have a row that then has a list of, like an order that has a list of items. Does that make sense? You can't do that with a table. Or I can't have a customer that has a list of orders. I can't get that as a result set because it would be not flat. Does that make sense? I can't have nested or embedded objects, right? So everything has to be turned into a row. And so the way we solve this, the way we implement these joins, is that we take smaller rows and we stick them together and make larger rows. So I might have one row with 3 columns, and I might have another row with 4 columns. When I join together, the result will have 7. 3 from one table, 4 from the other table. So any join you do, you'll get that kind of behavior. Does that make sense? Also, that means that the math of how many rows you get in your result set is usually not the number of rows in here plus the number of rows in here. It's not usually 5 plus 10. The math for figuring out how many are there is usually quite a bit more complicated in determining how many rows you get. Okay, so there are 4 or 5 different kinds of joins that you can do. So let's talk about what those different kinds of joins are and how they behave. So the first kind of join that you have, which is the base, simplest kind of join, is what we know as a cross join. And so one way you can write that is you can say from products cross join customers, or I could write from products comma customers, right? I can do that either way. You remember I said if I put a comma in my from, that's a cross join. Okay. So what a cross join does is it gives you every possible pairing of the rows in A with the rows in B. So in the result set, you'll say, okay, I've got my products here, I've got my customers here. I'll get a row for ball and John Doe, hat and John Doe, glove and John Doe, bat and John Doe, but I also get the same thing for Mickey Mouse. So Mickey Mouse ball, Mickey Mouse hat, Minnie Mouse glove, Mickey Mouse ball. So I'll get 16 result. I'll get 16 results in this, right? So with a cross join, it's always the size of the other times the size of one table times the size of the other, right? So you kind of think it coming out as a rectangle, right? So cross joins always give you a whole lot of records, right? And honestly, they are the most simple joins, but they're joins you should really, really avoid. If I've got a cross join, and let's say I've got 10 rows here and 10 rows there, put that together, I've got 100 rows. Let's say I've got 1,000 rows here and 1,000 rows here. I'm already at 1 million. I'm already 1 million from the results of that cross join. So cross joins are really something you want to avoid, and especially avoid a cross join if you don't have a where. Because a where, at least you can filter some of those pairings out. But if you don't have a where at all, yikes.
There's only one column on the left. I get you. It's like 4 times 4, but what if there were 2 on the left?
What do you mean?
Well, you just have ID. Well, all right, you got your ID as well, but I mean, there's only really one column.
I've got 2 columns and I've got 3 columns.
Okay, so it's just.
But we're talking about rows. We're talking about rows. Whatever kind of join I do here, I will get five columns. All joins will give you 5 columns.
Okay. Okay, 5 columns, 16.
But the problem is that 16.
Yeah, so it's basically the number of rows.
But that's the only kind of join I can do here, right? Because do products and customers have any sort of connection? They don't, right? There's no foreign key there's no relationship between products and customers. Mm-hmm. So the only join I can do between those two is a cross join because there's no relationship.
What would be a use case for doing that? Like just if everybody's issued like a inventory list or something?
Largely dates, largely calendar kind of things. So I want to say like, give me the 30 days, give me the last 30 days, and I want to see, here are the orders that happened on each day. Those are places where you can use this. So if I were to do this cross join, here are the 16 rows I get, right? So I get ball gets 4 rows with each customer, hat has 4 rows, 1 for each customer. Glove has 4 rows, bat has 4 rows. So that's the data I get if I do a cross join. Now, it's worth paying attention to this because all the other joins we do are kind of a simplification of this cross join. Does that make sense? Following with me? So this is what a cross join looks like. Next, let's talk about an inner join. So an inner join is actually the one we use the most. Okay. Cross join we pretty much want to avoid as much as we can. Inner join, on the other hand, is oftentimes the kind of the go-to default option. So if I want to take order items and join that with products, well, I can join those because they have a foreign key, right? And so I can do an inner join. So if I take that, let's say we've got these order items here, right? And you can see they've got an order ID. You can see they've got a product ID, right? So what column do they share in common? What column connects them? The product ID, right? So I can take product ID here and join that with the ID here, right? That's what I'm using in my on. So I say inner join and then on. You'll remember cross join doesn't have an on. Okay, so cross join doesn't have an on. So that's what that looks like, and I need to specify which tables are there. So order items, product ID, products ID. And the reason I need to put the name in there is oftentimes you need to disambiguate which table is the column coming from. In this case, I could just say product ID equals ID. Sort of. Product ID is unique between these two, but is ID unique? Actually, no, it is. It is. I take that back. It is here. So there is only one product ID. There is only one ID. So it would be valid SQL. SQL would let you say product ID equals ID. But don't do that. If you're going to do a join, always specify which columns which table is that coming from. And part of that has to do just with readability. Because if I don't know your schema like the back of my hand, right, and I'm looking at this and you just say product ID equals ID, I don't know if that's going to work. I don't know what that's going to do. But if I see that you have the table names there, then I can see, oh, okay. I know what you're doing. I know what to expect. So what happens if I inner join these? Well, what it does is it says, okay, let's take those pairs that go to each other and put them together. So if I start with the left, right? So this first row has a product ID of 1, right? So that's what I'm getting on the left, right? The 1144 is coming directly from here. But then on the right, see, I took the ball row, pulled down, right? So I'm taking 1 row from this table, 1 row from that table. Next one, I'm looking at this row. So this is product ID 2, right? So I take the hat, plug that in. 1 row. I take the next we've got this row. Okay, you'll notice that this is another order, right? But it doesn't matter because it's not the column we're joining on. But it's product ID 1. So ball again, glove again. Okay. Right, sorry, and then glove is product 3. So I go through the product AB basically here, and then I go find the corresponding row in the other place. Does that make sense?
Can you join your tables?
Yeah, I just would add another inner join. You can join with infinitely number tables.
Okay. I've never seen it done. It's possible, but.
Oh, it happens all the time. When I was working in the software industry, we had what was it? For the most common thing that we did, there was like a 7-table join.
Oh gosh, that sounds like a nightmare.
Yeah, it was. But yeah, there were to get down to the actual data that we cared about most of the times, it was a 7-table join. It was like 7 tables to get down there. From the top of the people, and this had to do with. So it had to do with surveys, is to kind of put things in context. So at the top level, we had that's actually not at the top level, but roughly at the top level, you had the people that were part of this survey, part of this study, right? Which we called them subjects. Medical name. So subjects, and then they'd also connect with in there your site, protocol, and sponsor, which had to do with how they were categorized. So the site was where were they participating in the study. The protocol was the study that they're participating in, and the sponsor was who was paying for the study. So you had to join that in. It's 4 tables right there, just to find out information about the subject. And then we needed to find out which questionnaire did they take. So then you joined in the questionnaire. Okay, we're at 5. And then you had, questionnaires have questions. Questions number 6. And then I finally can get down to the response on the question, which is table number 7.
Seems like a lot of work for a little bit.
Yeah, but if you need it, I mean, what if there was a winning lottery?
Honestly, SQL was not the right answer for that problem. SQL was the wrong tool for the job. We didn't know it at the time. So yes, you can get a lot of joins, and suffice to say that was not very efficient to have that many joins. Especially when we got down to the responses, which was that lowest level, and the responses had 1 million plus records in it. It was really, really slow.
Was it just that it was a legacy thing that just went age old, no one wanted to update it?
When did I start at that company? 2014, 2015?
Okay.
This wasn't that old. We're talking about 5 years old. Okay. 5 years ago. So, no, it's SQL is a thing that's been used for a lot, is used a lot in companies around town and things in the industry stuff. Anyway, so back to this. So you can kind of understand. We've got 4 records, and we've basically got those 4 records because for every item, as it turns out, every record in order items, we're getting 1 row in the result set. Do you see that? Now, why do I get 4 rows, and why is it the order items that determines that? Any thoughts? Let's go back to the ERD. What's the relationship between products and order items?
ERD, product ID.
Okay, what's the relationship? What's the multiplicity? Is this a...
It's 1 to many.
It's a 1-to-many relationship. But which side is the many?
The many side is the order product.
So order products. Products is the one side. That's why we have these records. Because they're on the many side, when you get an inner join, it's the many side that really determines how big your result set is. So if my many side is 10, I will have 10 rows in my result set. I can tell you that, which is great because that means I'm not going to have 100 as well, right? So I can kind of say I know how many rows are in the many side. I know how many rows to expect. Also worth noting though, you see on this, can I take this table and get back to the products table? Take this join table and get back to the original products table?
Sure.
So you say yes. Daniel, you say no. Why not? You're right. I don't have everything. What am I missing?
Aren't you linking it though? That's the whole point of the join.
Bat. I don't have any bats in this result set. Why don't I have any bats? Because nobody bought it. Nobody bought a bat, so therefore there's no bats in my result set here.
You have to do an outer join.
Yeah, I would have to do some sort of outer join, right? But so in this here, I don't have any bats, right? So I couldn't just go back and say, well, take this result set and let's get back to products. And notice that I have 2 balls, right? Because 2 people order balls, right? So order 1 and order 2 both contain balls, so there's 2 copies of balls, right? So you'll see once you do this join, you have not only duplicated data, and you also have missing data. Both of those things are okay, but that's kind of like why you have to do joins, right? And why you have to store the data in the original form, right?
So this is one of the things you have to be aware of with the inner join.
Right. You're not going to have everything. And so those are kind of the deals. So if I were to say do this inner join, right, from here, can I figure out, could I go back and generate a report with all of the products that tells me like how many times they've been ordered? Could I group this down? Because I could group by what? I could group by the product ID, right? If I group by the product ID, I'd go down to how many groups? Huh? 3. Why 3? Right, because nobody bought the bat. So I've got a group for ball, hat, and glove, right? So I would get a group and that would tell me, I could say, well, okay, I've got 2 orders for ball, 1 order for hat, 1 order for glove, right? So grouping is very helpful for, like, do a join and then do a group, right? Because then you can say, well, how many of those records are. So
group by product name, right?
No, group by the product ID.
Oh, okay. We could do product name as well, right?
You could do the product name, it's just slower. Because grouping by a string is slower than grouping by an integer.
Oh, okay.
So it's the same result, grouping by the name or grouping by the grouping by the name or grouping by the ID, but
it's not very readable, though.
Grouping by the ID is quicker.
It's not very readable though if you're looking at the result.
But you can put the name in there in the result set. You just want to group by the ID. You can put the name in the result set. That doesn't stop you from doing that.
Oh, I see.
Okay, so that's kind of how your inner join works, right? So we've seen the cross join, we've seen the inner join. So I'm going to jump over to is quick math lesson. What time are we at right now? 2:30. So let's take a break. So you may have heard the term set theory before, right? Where have you heard that term before? Not in programming class, probably.
Set theory?
Set theory. What about?
Jeopardy, maybe?
You've maybe taken some math classes recently? Possibly some college level math. They probably talk about sets at some point.
Not in 20 years.
Okay. So this part you should have learned in math class, and you should have learned, for instance, that my marker's dead. You should have learned things like A, right? That's the intersection of A and B. And you should have learned this is a union B. Okay. When you're doing joins in SQL and select statements, all of that comes up and is very useful, actually. It's worth noting there's a reason that these are like this, because this is an OR, a union is an OR, and a intersection is an AND, because this is it's in set A or it's in set B. This is it's in set A and it's in set B. So one of the things, you probably didn't run into this, the way we write OR in kind of upper level math, this is an OR, that's an AND. Notice that they look very similar. Anyway. So just trying to jog your memory up. So that's, you remember seeing those symbols, the union symbol, the intersection symbol? That was set theory. And you probably saw Venn diagrams with it too. So you may remember Venn diagrams look a little bit like this. You have set A, set B. Here we're going to talk about as tables. Table A, table B. Because basically a table is a set. Or a set of records, results, is a set. So any set of rows, you can treat it as a set and think about it as a set. So we have, here we have the area, the things that are just in table A, the things that are just in table B. You have the things that are somewhere in the middle. They're in both table A and B. And you kind of can think about, your foreign keys, your inner joins. Inner joins actually get its name from this diagram. So if I'm looking at this area in the middle, we call that the intersection. Okay, so the area in the middle is what we call the intersection. If you're taking the area as a whole, that would be the union. Right? The union is everything put together. If we're wanting just what's in A and not in B, this is a subtraction. I think some variants of SQL use the word except. But in general, this is a subtraction. We're saying A minus B. Okay. Any questions on those diagrams? You can see what all of that looks like. So let's connect that to joins. So if I'm creating an inner join, what I'm getting is this. I'm getting the area that's in the middle where there is a foreign key primary that match up. Right? So we could say probably one of these sides is going to have the foreign key, one of these sides is going to have the primary key. Inner join is only those that match up, which means that you'll notice that there's some area out here that isn't covered, which actually usually this area here are usually pretty small, but that can be done. So for instance, we saw bat, right? Bat didn't show up in the result set because it lived over here, right? Because bat had never been ordered, it was over on this side and not in the middle. If we had a order product, but the product that they ordered was missing, right? Maybe we, for some reason, had lost that product. Well, then it would be over here. We have the order product, the record that they purchased it, but not the name of the product. So that would live over here. Cool. So you can have some things that end up on this side, some things that end up on that side that you don't include. If I want to include the stuff on the left, I use a left join. So left join is this. That's conceptually what a left join is. It's the whole left circle, including everything that's in the intersection and everything that's not in the intersection. Okay? Similarly, a right join is everything in the intersection and everything that's on the right. So it's the whole right thing. Okay? So the reason I use the left join is if I need this data. Use a right join if I need that data. You use a full join if you need both. Does that make sense? you need stuff that's on both sides, and you use the full join.
In the real world, when we're doing this stuff, we just do a query and see if you like what we get, and kind of just hone it from there. You don't just set out saying, what we need here is a left join.
You do set out saying there I need a left join. Because honestly, yeah, you do actually have to set out there. Because finding out that you need a left join instead of an inner join is those bugs are hard to find. And you usually won't find, you might find that from a bug, but the odds are you're probably not going to find that until a month to 3 months after you've introduced that bug, if you're not thinking about it ahead of time. If you're saying, like, I'm not going to plan for this, I'm just going to write it all as inner joins, yeah, you're not going to catch it until months later. So no, you do have to generally think about it ahead of time and say, yes, I know I need a left join here, and I know I need an inner join here, and I'm going to write it that way from the get-go, because I know that that's going to be a problem. So, cross joins can't really be represented with the Venn diagram. There is no way to really represent that with the Venn diagram. And you saw that idea of exploding, with the Venn diagram, you're getting rows that don't exist, basically, is the thing, right? You're getting all the pairs of A and B that are possible. So the best way to draw a cross join is with a rectangle. Table A, table B, and then everything inside of it is the possibilities. So union, basically taking two tables, and a union, the way it kind of works is basically you take all the records here, and then you put all the other records down at the bottom. So a union kind of looks like tacking on two tables on top of each other, concatenation.
They're unrelated.
They're unrelated, typically.
It's like a yellow sticky note with grocery items and
yeah,
school supplies or something.
So let's say, I think originally when we kind of talked about the cowboy boots, I think one of the suggestions for modeling it, some people had suggested, well, let's take our products and let's split it up, right? So we'll have a table for hats, and we'll have a boots table, and we have a hats table, a boots table, and a belts table, right? Well, if I wanted to put all that back together, that would be a union. So if I said union belts with hats, with boots, then I would have one large table of those three smaller tables. One of the rules with union, though, is that you have to have the same columns, basically, when you put them together. So you can't just pick 2 or 3 random tables and put them together. You basically have to massage them into the same columns and then put them together.
There can't be any more or less. That's
Well,
exactly the same number.
Exactly same number, same data types as well, because you literally need to be able to just take table A and stack it vertically is the goal. So let's talk about how we implement those joins with knex. Okay. So if I'm writing the join in SQL, I might say from order items, join that with products, join it this way. The way I write that join for an inner join is I just say join. So join the name of the table that I'm joining in, and then the 2 keys that I'm joining on. So join products, order items, product ID, products ID. See that? So that's how you translate the join. Questions? Daniel, did you have a question? Okay. It just looks like you're looking quizzically, but okay. Okay.
Speaking next is difficult.
Yeah, that's fine. So that's kind of the language translation. Left join's a very easy translation. You just change this to left join, and from join it goes to left join. So otherwise, it's the same syntax. Similarly with right join, you just put the word right join instead of left join. Now, in general, one of the things I'd say just as a convention, avoid right joins and full outer joins. Left joins are great, but you usually only want lefts and inners. So usually one of the things you can do, by the way, is reorganize. You can oftentimes reorganize a query to be a left or a right. So for instance, if I'm saying left join, right, I'm saying order items to products. Well, which table there is the left table? It's order items, right? So the left table here is in that from. That's order items is the left table. The right table is products. If I flip that around and wanted to do the same thing, where I went from products to order items, it would be a right join. Does that make sense? So if you change the order of the join, you also change the direction of the join. So you can oftentimes take a right join and convert it to a left just by swapping the order that you do the join in.
Why are outer joins a bad idea? Why aren't they?
What do you mean?
You said most of what you're going to be doing are inner and left joins. Why would that? What's wrong with that?
So the problem is that the rights, first of all rights can be generally converted to lefts. Rights are harder to read. It's harder to understand what the query is doing if you're doing a right join, because right joins are weird. Left joins are pretty intuitive, as long as you go from the one side to the many side. That's what I would stress in the way you order things. If you start with the multiplicities, the lows, you say ones, go to many, one to many, one to many, one to many. If you go that way, you can always do inners and lefts. The only place where you need a right is if you go from the many potentially back to the one.
If you wanted to connect that, it's order items and then product order and then product, right? That was the order. The bridge table was in the middle.
You said what was it? It was what was the first one?
It was order items, right?
Order items. You said order items
and then isn't there like product order in the middle? It's a bridge table.
No, the order items and order product, same table. I'm just calling them I just called it a different name here.
Oh, okay. Let's say you did have a bridge table in the middle, though.
So that is the bridge table. So
What is the bridge table? I'm sorry.
the order items is the bridge table. So.
Oh, okay.
Yeah. So if I said go in the middle and I then went to orders and products, right? Well, then I potentially would need a right join and a left join, right? I might need a right join to go to, what would I need? Well, I guess both of those I would need a right join. If I started with order items and went out, then I might need, then I might need a right join with products to make sure I get all the products, and I might need a right join with orders to make sure I get all the orders. But if I go from one side to the other, if I say orders, bridge, products, I can do left the whole way, or if I do products, bridge, orders, I can do left the whole way, usually.
That would be the representative way if you're working with the bridge table, is to do a left join.
Well, the trick is you don't put the bridge table first usually. It's you put it in.
Yeah, that's intuitive enough. Yeah. You go from one to the other.
Yeah. So unions, the way you write union in SQL is like so. You say select star from boots, union select star from hats. Okay. So that's again going to take the results, let's say the rows and the boots table, the rows and the hats table, and plot them together. Assuming they're the same structure, like let's say they just have an ID and a name column, that works fine. But if they say they have, boots has a size, a color, and a style, but hats only has a size, right? Then I need to eliminate those other rows and say, well, I just want the ID and the name so they match up. So typically you're going to not have select star with those. The other thing that happens oftentimes, there's actually two versions of union. There's a union and a union all. Union gets rid of duplicates. If you have duplicate rows, it will go and find them and get rid of them. Which more than often I find, actually, if I'm doing a union, I do want to keep the duplicates because they're not actually duplicates. Or I know that there won't be duplicates, so I want to skip that inefficiency of having to go find them. So if you say union all, it doesn't remove the duplicates. So usually that's what I use instead, is union all instead of just union. But the way we can translate that knex, you say knex union, and then you put each of the queries that you want to put together inside of that union. So it's basically an array of queries. You see that? So you give union an array of queries. It'll stuff those all together, give you a single query, if you do need that. Okay, so that's the end of my slides here. Any questions, whether in person or online, about some of the theory there? So we kind of saw the syntax conversions, like here's what you can do in SQL and why you might want to do it in SQL, but also the translate it over, right? Here's what it looks like in one language. And for the most part, most of the things I think you see translate pretty easily. It does take a little bit of looking, a little bit of digging. There are some examples in there that I didn't actually find on their documentation, so I had to test them and see if it worked. But most of the things translate pretty easily. Okay. So what I want to go from there and do is look at a code example, and we'll do this. We'll do more as a code walkthrough than a code along. So I've got the finished code here, and what I want you to do is pull down the finished code. Okay. So if you go out to GitHub, because I want you to pull down the finished project so we can look at it together. This is the repo you're looking for. And I'll link it in Dixtord. I think, Ben, you got this one pulled down already. So if you haven't pulled down my repo here, please do. You'll want to clone that onto your computer. Yeah. Once you get it pulled down, you'll so once you get it pulled down, you'll go into Unit 2, Examples, and what we're going to pull up is Cowboy Boots G. So Cowboy Boots G is what you want to open in Visual Studio Code.
What's going to happen is oh, okay. Yeah, if you do that, you're going to download the entire thing every time. You just go where you want to pull it down. Right there. Now you don't want to put it in the middle of the backside. So you want right there. It's right there. Oh, yeah. So unit 2 examples, and it's probably these two. That will be much faster than that one. But it also means sure. This is supposed to turn green, isn't it? Seems to be. How do you know if you're connected to get in sync or pull down? It's fine. It's okay. If you see that,
Sure, did you get that sorted out? You got the code pulled down?
Yeah.
Okay. So first things first. So basically what we got in here is I've gone and done a number of the things for this week, so you can have the finished code and see where they go, how to do all those things. Because I figured it'd be easier to have a version of the finished code than write it together for these things, because we've kind of talked about how to do most of the stuff, so you don't need that part. You just need to see, well, this is how I solve that kind of problem now. So that's where we're going to do this here for this week. So one of the things in here is I have changed the database a little bit. So we used to have the order product table. I've renamed that to the order items table. So that's the bridge table in between orders and products. Okay. And I've also added the customer table, which wasn't previously in here, because I wanted to do some of the pages related to customers. Okay. So what that all means, before you can run the application, you'll need to actually make sure you run the schema script again. So going into Workbench, I'm going to pull up that schema script and execute it to make sure you're at the same database that I'm at. Okay. So I've already got it loaded. Obviously, if you want to load it again, you're going to go to File, Open SQL Script, and you're going to go to Unit 2 Examples, Cowboy Boots G. It's under the Data folder, and then we're going to run this. So once that finishes executing, you should have some rows, some data in all of the tables. Okay, so I've got my data up and running. Next, I want to actually start the server. So I'm going to go into terminal. And remember, first we're going to say npm I or npm install to get all of our dependencies up to date. Because remember, the node modules won't have come with the code that you got. So you want to make sure you do npm I. And then once you've done npm I, we can actually go into here and start it. Cool. So the server's running, right? So this version of the website's got a few things in it. I've gone ahead and switched the theme over to Lux. So it was the default theme. I've switched it over to Lux just to make it look a little bit nicer and kind of see what can happen if you just change the theme, right? Because it can have a big impact on your styling. And what I've got in my nav bar, you see I've got products, I got customers and orders. In reality, this is stuff you'd probably want to put behind an admin screen, right? But I'm not worried about that right now. I'm just trying to make the functionality work. I can later move where it is without too much difficulty. So if you look at the nav bar, you should see orders, you should see customers, you should see products. Does everybody have that?
npm install not working for me.
I didn't do it.
Okay.
Give me a bunch of errors. I don't know if it. Right?
Yeah.
Twice.
Okay. I'm not sure why I need to do that twice, but
Yeah, okay. It's working.
So get that up in the browser.
I didn't see that possible.
okay. You had a question? Okay. So customers, we kind of had already looked at the products, and this is the pages that we'd started to build, with the CRUD for that. But what I've gone ahead and done is added pages for orders and added pages for customers. So, for instance, if I look at the customer list, you can kind of see what I've got here, right? So we've got the name, the first and last name of the customer. We've got the email. I've got something here that's saying how long ago it was that they registered. So registered 4 minutes ago, and we'll look at what that is. That's going through something called Moment, which is another library which is really good at working with dates and times. So Moment is what's generating that text. And then you'll also notice I have this text then on the bottom. It says 0 orders placed, etc. So this one says 2 orders placed. If I go look for John Doe, you can see he's got 4 orders placed, right? So I want to get, let's say I want to get that data, right? Let's say I want to display this data. I want to be able to show how many orders that John has placed, right? how can, with the select and the query stuff that we've gone through, what can I use to get that data that they've made for orders? Obviously, I have to start with the customers, right? What tables do I need to bring in order to get that, though?
Their number of orders.
The number of orders?
Yeah, if you pull up the RD.
Mm-hmm. So let's look at where that data is stored, right? Where is the number of orders that they have?
You just need the order table. Just count.
Okay. So I need to bring in the order table, right?
Yeah, that'd be the only thing. You don't care about the ID or treating anything else other than the number.
So let's try writing out the SQL for that. So I want to say in here, let's make a new query. Let's say set as default and select star. I need to make this a bit bigger. There we go. And that seems to be as big as it'll get, which is oddly small. So select star from customers, right? So I know that my query is going to start with that because I'm trying to give a list of customers, right? It has to start with that effectively. I also want to bring in the orders, and so we were looking at the ERD, and we can see that it's connected, right? There's a one-to-many relationship, so I know that I can use that, and I know that there's a foreign key there. So let's say I want to join those in. Okay. Now, what kind of join should I use?
Left join.
Why?
Because it's a one-to-many.
It's a one-to-many, but couldn't I use an inner join?
You could in this case.
I mean, with a one-to-many, you can use any of the three types. You can use any of the types of joins. So the type of the relationship doesn't tell you what kind of join you want to do. Okay. So let's say I do select star from customers. Okay. Just as a look there, how many customers do I have? 101, right? So if I do anything that gives me less than 101 customers or more than 101 customers, I know that I've done something wrong. Does that follow? If I get more or less than 101, I know that something isn't right. Okay. So let's say I do an inner join with orders it was. So orders, and let's shortcut this. So I'm going to call this C. I'm going to say orders is C, customers is C, and orders is O. And then we want to say on C dot ID is equal to O dot customer ID. Okay, so I can join those together. All right, so I've got rows in my result set. Can you see how many rows? Can you see what's there? Basically, we've got both of those put together. Right? So I've got given name, I've got family name, I've got email, password, registration date, ID, customer ID, payment date, and shipment date. So I've got information from both tables now, right? And if we pay close attention, we'll see, in fact, that I have 3 John Does. Why do I have 3 John Does? Because he's got 3 orders, right? Okay. Now, how many rows do I have? If I go down to the bottom, well, it looks kind of hard to tell. I don't know that there is. Does it actually show in the output? It looks like it says 103. Yeah. So it says we got 103 rows back. So right off the bat, I know that my number of rows does not equal my number of customers anymore. right? So I know I have actually more rows than I have customers. And I can kind of tell that that makes sense because I can see John Doe showing up multiple times. Right? I can see the same customer show up multiple times. Now, how can I get back to not having multiple rows? How can I get... Huh?
How do you avoid multiple rows with the same name?
Well, I want to get back to 1 row per customer because that's my result that I'm going for, right? I'm going for a result that shows here's all the customers and here's each of the here's the orders that each of them is placed.
Oh, I was thinking like by a combination of given a family name, but you need something more specific because it could be you could have 2 people named John Doe.
Yep.
So by email, something that's
Okay.
unique.
So I could do by email. I have the ID. Why? Okay, so the email is unique as it turns out. The ID is unique, and actually the ID is always unique. The email may not be unique, depending on your requirements. But there's a difference in performance because the email is a string and the ID is a number. So given the choice between string and numbers, you should always choose number. So let's use that and maybe group by. So let's group by the customer ID. And it doesn't matter if I use c.id or if I use o.customer ID, they're the same number. So it'll result in the same thing. All right, so now I should have 1 row per customer. Okay, which I can see that there's not 3 rows for John Doe anymore, right? But you should start to notice there's some gaps. 1 to 61. It also seems like everything's off in a random order now because it's not ordered even by the customer ID, right? It doesn't seem to be ordered in a sensible manner. And
it's
if
ordered by the other ID.
Is it?
That seems to be.
Oh, it might have. I might have maybe clicked on that. So anyway, we know we have 56 rows returned per the message down bottom, right? Which means that I don't have all my customers anymore, right? So if I were to leave it as this, I could get the number of orders, but I wouldn't have all the customers, right? I would know how many things they ordered, but I wouldn't have all of the customers. I just have some of the customers, and that would be a problem, right? It might not be a problem if you don't care about the customers who never played an order, which honestly sometimes you don't care about the customers who haven't placed an order because who cares?
That's my idea left join.
But if I do care about them, yes, then I do need a left join. So if I just do a left join, I will have all of the customers that haven't placed an order, and I get back to 101. So you might see that 56, and you know right away, or it might be the difference between 100 and 105, and you don't know if that's because you've just had 4 new people placed an order or whatnot, which is part of why you have to kind of look at that, first, and you have to look at that in a development environment, because if you just look at it in real data, it may not be that different. You may not spot the difference because of other things going on may wash out the difference between the right thing and the wrong thing. So let's say I want to get back to that. I also need to get back to the columns, right? Because now I have columns from the order table and I have columns from the customer table, right? So I want to get back to just the columns from the customer table. Okay. So you remember star gives you all of the columns? Here's a trick. You put the table name, which in this case I'm using the alias. I could use customers dot, or I could do c dot star. Is all the customers just from the customer, all the columns just from the customer table. Make sense? Okay, and then what I wanted, finally, was the count star, which is why we did this whole thing. Is I wanted to know how many orders each customer has.
And you can order those in descending order at the very end, right?
We could, yeah. So you can see on the last column, it shows you, the last column shows me how many orders they made. So for instance, I can see that John Doe has 4 orders, etc. I've got Janka Colebrook, which has 2 orders, right? So I've got that in my results set. Now, there is one conspicuous thing that you may or may not see in here. There's a lot of 1s. There's a lot of 1s and no 0s, because all of the 0s are being reported as 1s. All of the 0s are being reported as 1s. Everybody who has no orders is being reported as having 1 order. Okay. Now, if I go back to inner join, that turns out to not be a problem, right? I don't have any 0s, right? Because all the 0s are gone, right? But obviously I want to include the 0s, so I do need this to be a left. Okay. So let me go back to displaying all the rows, and maybe we can figure out what's going on. So we'll notice some of these rows here. You may be able to see this. There's a bunch of nulls over here. Do you see all those nulls? So for every, if there isn't a row that matches up with it, which is where the left join comes in, then all of the columns on the right table come in as null. All of them do. So if there is at least 1, that will be a value. Otherwise, there won't be a value there. See that?
How can there not be a customer ID, but they're in the... Okay,
because they made no orders. There was no matching order to go with it.
Line 2. Yeah, okay.
Because the information over on the left, it's the orders customer ID, right? The actual customer ID is over here,
yeah,
right? So you got the rows from the customer and you've got the rows from the order. So we know if it doesn't match up, right, all of those columns will be null, right? So we only want to count the ones where it's not null. Right? We only want to count the rows where it's not null. Okay? So how can we count the rows that are not null?
Where order.id is not null.
Well, if I did the order, well, let's watch that. So let's say I put a where in here, because this is a common mistake.
Or it's having, right?
Where order, what was it? Order.id, o.id equals null.
No, is not null.
No records, right? Because that fails all the time. That's what I told you, right? If you compare it with null. Okay. Is not. Okay. How many rows do I have in my result set? 56. We saw that number before, right? How did I get that number 56? That was before I changed it from an inner join to a left join. So if I do a where, I'm back basically to an inner join. Because I said I wanted to keep those records, and now I've thrown them back out. So no, you can't solve it with a where, and having would have the same problem. Because having and where, you're removing rows from the result set. Okay. So I can't do it with either of those clauses, because either of those clauses would give me 56. Okay. So what I want to do instead, remember that star, if I put in star, it's counting the rows. It counts the rows. Well, remember originally that there were 4 rows when we did the join, because for John Doe, because he had made 4 orders, right? So there are 4 rows. That made sense. But what about the customer that doesn't have any orders? Well, they still get 1 row. They still get a row, which is why they're being counted as 1, because we're counting the rows. It's just that everything else is null. So instead of counting the rows, I count the number of values that are not null. So in here, I'm going to put O.id. Now I have my zeros, because I count the ones only where there is an order ID.
Okay. Count O.id.
So I'm counting the primary key from the other table, which the reason I'm doing that column is because, remember, a primary key can never normally be null. Right? That's one of the requirements for a primary key. If I said let's count the O.price, or not price, payment date. Let's say I chose that column. Well, that one would give me the wrong count. See, so if I do that one, I'm going to get John Doe has made 3 orders, because they only paid for 3 of them.
It's only the ones they paid for.
Because it's only counting the ones where it's a non-zero value. Right. So similarly, if I do ship date,
okay.
If I do ship date, I get 1, because only one of those 4 orders has been shipped.
And if you want anything that's not a 0, then it would be where. It wouldn't be inside there. It would be the next line with it.
What do you mean?
Where count is greater than 0. Would you type that right there? Where count is greater than 0.
If I wanted that, I would just do an inner join, I think is what the answer is to what you're saying.
But you could do it there, right? Let's say you want to do that, like where count is greater than 0.
I don't want to do that.
Okay.
Again, that would be going back to an inner join. And then I should just go back to an inner join. So count.o.id, I need to give that a name, because you'll notice, for instance, how that shows up. Anytime I type in a count, you see the name of the column shows up as the actual expression. So if I do count, I need to make sure I alias it as something else. So I might alias that as order count, right?
All right, well, let's say you wanted to see who was ordered 3 or more items now.
Okay.
Yeah.
So if I want to see that, right? So that would be a case where, do I know how many items that they've ordered before the grouping, or do I need to do that after the grouping? You do it after.
Yeah.
Right. So if I want to say how many orders have they placed, I would say order, say having that expression, so count.id greater than or equal to 3. No, because the select happens after the having.
You mean the order of operations?
Yeah, order of execution. So that would give me the orders that have all the customers that have 3 or more.
Okay.
With me? So one thing was asked, I have these now arranged this way. I haven't ordered it. What would be a sensible way to maybe order the results? Huh?
Their name.
So I could order it by their name. That would be a great solution, and I could do that as given name, comma, family name. Or I could potentially order it to see who has the most orders. I could order it by the order count descending. And I can use the alias there, as it turns out, because the select happens before the order by. So then I can see, well, what are my most loyal customers, right? Order by the order count descending. So there's a lot of places that can be, you can feed that into your website and produce usable data, but you do have to kind of understand the select queries underneath it, right? Cool. So you can kind of see, effectively, just to get that order count, how much did I have to change my query? Well, without it, what was my query? My query was select star from customers. And I don't need the order information anymore, right? So this is the query we started with no order count. That's the query we ended up with the order count. Quite a bit more complicated, right? So to get the order count, I needed to understand what concepts, what things did I have to add? I have to add a left join. I had to add aliases, group by, potentially order by, yeah, and count, right? So don't be afraid necessarily if you take a query that's like this compounds all the time. You start with a query that's very simple, and then I just want to add more data to it. Sometimes it becomes a much more complicated query. And talking about the business, recognize that you're going to have to convey this to your business. It's like, yes, it's not that simple. You just want me to add this piece of information. I know. But I have to join another 7 tables to make it happen. So, hey, that's, things to keep in mind, because if you're trying to estimate how long it's going to take you to do something, right, sometimes things with SQL are not straightforward. Okay. So let's look at the database, because I want to show you how this turned out when I turned this into knex. So when I go to, right, okay, so here's my query to get all the customers, right? It's just knex customers, select, and I'm telling it what columns to pull out. There's my version, right? So I call it get all customers with order count. Right, so we've got the knex, we've got the left join, we've got the group by, got the select, and then I'm also adding the count. So does that kind of make sense? Does that help with the translation process as well?
I had to study it for a little bit, but yeah, it's helpful to see a real example instead of a theoretical one.
So that's where I thought, at the point where we're at, it's probably better for you to see some more fleshed out example code, because we've got the basics, right, to see where you can start pushing some of these pieces together. So that's how we would write that query. Effectively, I'm pulling that data back in. Let's see. So routes. This would be the customer list. Okay. So ignore some of the stuff I have here. Basically, I'm calling that, and then I'm rendering the view. Okay. So rendering the view, I'm rendering the customer list view. So the customer list view is over here. Okay. So collapsing this for a moment because this is related to our search. So I've got a div, I've got this. Okay. I'm doing something interesting with my customer list. If you watched all the videos that I put on Perusal, you may know what this is. It's a partial view. Okay. So what I did is I extracted this, and this is helpful for other places. So for instance, as it turns out, I actually show the order list in two places. So for instance, if I look at the customer, right here I'm showing the list of orders the customer has placed, but I can also go to the orders page to see all of the customers and all the orders and search it. So both of those places, I'd like to use the same code. So a partial view, using a partial view for both of those lists, lets me use the same code. Does that make sense? So there's a lot of benefit in taking your list and actually making it a partial, because then you can use it in multiple places. So that's what I've done here. So I sent the way that you tell that it's a partial is that little caret there, a little greater than symbol. So curly braces greater than says that you're having a partial here. So it says that the name of the partial is customer list, and then the data I'm passing it to is the list, the array of customers. Cool?
I'm not getting why it's a partial. Like what does it do as opposed to?
Customer list is a separate file.
Where is it at?
We'll get to there.
Okay.
So this is a separate file. So, but the point is, this is the name of the file, right? It's customer list,
Okay.
And that's what we call the context. Okay, that's the data we'll be working with. Now, the place we find the partials is in a special folder named partials. You do need to make sure you name that folder partials. If you name it partial or part or anything else than partials, it won't be able to find your partials. So the folder is required to have that name. Okay, so if I look in partials, you see the customer list.handlebars file. Customer list.handlebars. That's where it is. So it's bringing in all this code, which is where I'm actually looping through and generating that list of customer cards. Okay. So if I look at that, right, we do each. And then notice I'm doing this. Well, what does this refer to? The thing that's passed in, the context. So because I passed in customers, right, that would mean that. If I'd instead said this and passed this in, then over there it would be customers, because I would be passing in the entire context, not just part of the context. So I passed in the customers array, which means that that's the context it has. So then we loop through the customers and we display a card for each of them. And from there, most of the things are fairly similar to what we see. Now, you may notice, remember I said the registration date, you saw it was saying how long has it been since they registered? So if I say here, you see says registered 34 minutes ago. So the place that's being generated, you see here it says registered from now register date. What'd you say? Okay. So I'm saying from now register date. What is this from now thing? Any guesses? Thoughts? It's a helper. Right? So where have I defined that helper? Where could I go find the definition for that helper? Server.js. Okay. So back in Server.js, there's my helper. So here I'm using a library called Moment. Okay. You can install it fairly easy. You just do npm I moment. But Moment provides a lot of tools for working with dates and times. Makes it very easy to do things like parse a time, format a time, add and subtract days, add and subtract minutes. There's a lot of things. If you're working with dates and times, which any application you build will be working with dates and times, because you always want to store things like how long has it been, when did the user register their account, when did they last log in, when was the order placed, when was it shipped. Any system you build will have a use for timestamps somewhere. So Moment is a generally useful tool for whatever you're building. When you're working with JavaScript directly, JavaScript does provide some date and time tools, namely in the form of the date class. Okay. Unfortunately, the date class doesn't provide a lot of stuff. It does provide a way to, say, turn it into a string, but it doesn't give you a way to like format it and make it look the way you want it to and such. So the date class itself doesn't provide a lot of functionality. Well, what we get out of the database, if I say get this data out of the database, knex will actually pull it out, and I think it actually comes from the MySQL library underneath it, pulls any date or date time columns you got out of the database as date objects. So in order for us to work with them in Moment, we have to take them from date objects to Moment objects. You actually don't really care though. In fact, if it's a date object or if it's a string, strings also the same way. If you want to take a date object or a string and convert it into a moment, you just say moment, call the constructor, and you pass in either the date, whether it's a string or a date, it'll figure it out. It'll turn it into a moment. So that's basically my moment constructor. So I say, if there is a date that you gave me, let's construct a moment. And then from now. From now is what actually generates that string that says it's been 54 minutes or whatever, or 3 hours or 2 days.
Or whatever you fire up the server, right?
Yeah.
From that time, right?
Yep. It's measuring how much time is it now from when I registered, which they're getting registered at the time I inserted the record.
Well, I saw it was 4 minutes when you started, now it's 34 minutes. So it's about the time you started the server, right?
Yeah. Well, it's the time I ran the script.
Oh, okay, well, that.
It's the time I ran the script. So that's how I'm doing that formatting. So I'm using Moment for that.
That syntax there, format date, sign, that's all in the npm.js.
Yep. So if you look at if you go look at the Moment website, I think it's momentjs.com. They've got a lot of good documentation for it. There's other places on the internet you can find it, but most of the most useful stuff is right on their homepage. So there, so you can find out most of it just looking at their main page.
Install data, that's at the top right there.
Mm-hmm.
Okay, I see. It's in there where it was
npm install Moment. Simple as that.
I know beyond that where it was written in the actual helpers that you wrote. Was it like that? It was different, wasn't it? Like from now and all that.
Yeah, from now.
Okay, that's it. That's what you have written there. I thought it looked different.
It does look a little bit different because they're doing they have something more complicated. They're saying end of day, yada yada. Yep. Yep, that's exactly what it is. So if you have anything you want to do with dates and times, absolutely look up that library. It's a great thing to be using. And if you look through the example code I've given you, you'll find, and you just look for places I'm using Moment, you'll find quite a few actually, because it turns out to be, as soon as you start doing dates and times, it's like, okay, forget about the date class. Let's just use Moment. So a few things I'm doing. So for instance, you'll see I've got a method to format the date or format a date time. I'm using these formats, 3Ls, 2Ls. Those are some built-in formats. You can find out about those on their website. The place I'm using that, if you go to the list of orders, you'll see that this says purchased a month ago, but you'll see in the brackets September 3rd, etc. That's where that format date is being used. Utilities.
Okay. And documentation is pretty straightforward.
Pretty straightforward. Yeah. Moment is probably one of the easiest libraries to learn. So you can kind of dig through that. If I look at any of the customers, let me go back to John Doe. So if I go through here, you can see I can get a view of the customer. That view includes some pieces of information. Same thing we saw on the list. The name, the email, how long has it been since they registered. But it also includes the orders, right? Also includes the orders. Now, it's worth asking, you saw that I could do, what we did is, remember, we figured out how to figure out how many orders they had? However, I can't necessarily generate this entire page with one query. We saw how to do the other thing with one query. This is a case where I can't, because I need to get the customer information, which gives me a single row, and then I need to get the orders, which gives me multiple rows. So it actually does require 2 trips. So if I look at that route in the customer, you'll see I go grab the customer, and then I say, well, if there's a customer, let's also go grab their orders. So there's 2 trips to the database. 1 trip here, and a second trip here. So if you need more than one query, that's how I do it. And that's part of where the await comes in easy. Okay. If I dig down further and look at the order, and get one of these orders that has 2 items. If I'm looking at order, there's actually more than one place where I might want information. So I want the items that are in the order, but also in the items, I probably want to know what the name of the product is and such. So that's another thing in here. So I'm, in effect, to build this list, I'm pulling data from order items and products. To give the information up here, I'm getting orders and I'm getting customer. And then the total cost is a whole nother kind of calculation. But the total cost I can get from this information that I have here already. Okay. So let's look at some of those queries that build out this page. So this is the order view page. Okay. So I go grab the order first. That one's pretty simple. And we can look into that one, but it is, I just go get the order. If you go hold control and click on a function, it'll kind of pop it out here and give you a preview. But you can double click on the file and bring it up and have it locked. Yep. So in the pop-up, you see the file name.
Oh, you clicked on that then.
Yep, double click on the file name, it pops up. So I can use control to get there. So if I want to get the customer, I want to get the order, and do that. The next thing is to get the customer. Get the customer ID is pretty straightforward because once I've got the order, right, order includes the customer ID. So I just say, well, let's go get it, right? I've got the customer ID. Does that follow? You just have to wait for that, right? You have to wait for the order to come back in order to be able to have the customer ID. So you can make another request there. Okay. Now what about the items? Okay, so I've got get order items. Okay. So I've got some information in the order items. This could actually be an inner join. I don't remember why I made it a left join, but this could be an inner join. Or order items, join to the products, and then I just say, well, what's the data I want to keep? The one thing that's worth noting there, when I pull back these three columns, you'll notice that I'm aliasing them. So here I say order items dot price. I'm aliasing that as price paid. I'm aliasing the product dot name as product underscore name. Product's price is list price. And that way I have a well-defined name. I don't have two price columns, if that makes sense, or two name columns, etc. I know where they came from. So when you do a join, it's often find that you need to alias all the columns from one or two tables.
Would that still run the same if that where on 161 was up high?
Yep, it would still run.
The order doesn't matter.
Order doesn't matter with knex. So I could do that earlier, I could do it later.
And let's see. Okay.
And then finally, I'm doing some calculation for the total cost. As it turns out, because I've already got the items, I can just do that in JavaScript, right? Because I already have the array of items, I can just do that calculation in JavaScript, which is what I'm doing. So I'm using Lodash to do that. Remember we talked about Lodash? So anytime you see this underscore, that's what we're happening here. So Lodash.sum says go add things up. And it works very, similar to how the other one is. So I've got two things going on. I've got a sum, and I've also got a map. Okay, so I take the items. First thing I do inside is I take the items, I map them to a calculation here. Because effectively what I want to do is I want to calculate the price for each of those items in the order. Cool? So that's quantity effectively times price. Okay, but I had to do something interesting with the price. Do you see what I did?
What if there's both? Then what would happen?
What would happen? Huh?
If they both have value, just stop when the first one.
Let's stop at the first one, right? So what's the first one? Price paid. So if they both had a value, then the first one would take over. So I say, let's take the price they paid when I'm calculating the total cost. Prefer that, but if the price paid isn't there, we'll use the list price instead. Follow? So if there is a price paid, we'll use that. If there is no price paid, then we'll use the list price instead. So that effectively takes this array of items, right? Map takes it from one kind of array to another array. So we take an array of items, transform that into an array of prices, numbers.
Map never changes
numbers.
The array.
Map never changes the length of the array, right? So we map that, and then we just add it up. So that's how I got the total. Any questions? Okay. Look through it, see what you see. I've got the search pages in there as well. So you can kind of play around with that and see how those are implemented, for instance. So I can type in names on there.
You mean already at home how to do a search?
You can play with it around. We're sitting at 4 o'clock, so we can look a little bit around it, but there's a lot there. Mhm.
Partial view, it's as simple as just adding the partial.
Yeah.
Not doing more value.
No.
That is awesome.
You just say, hey, I want a partial, so you just put it into the partials folder
You've got a reference.
and just use it.
Wow, that is awesome.
Yeah, you just put it in the partial folder and use it. Huh?
I feel like it wasn't that simple.
It's like a little snippet
Yeah.
thing, right?
I think actually in MVC it was pretty close to that.
I don't really remember. We only used them like one time.
Yeah, I know several students used it a lot.
I know Graham like
Graham used them a ton, but
So it's like a snippet, right?
yeah, that's really all it is. It's just a
Yeah,
snippet.
that is.
It's a piece of a view that you can just reuse other places. So sometimes people will take things like your nav bar and make that a partial.